Everyone. Thank you for joining us today for our webinar on the latest version of TigerGraph Database 4.3, built for enterprise security, integration, and scale. I'm your presenter today. I'm Victor Lee, Head of Product Marketing and Distinguished Graph Specialist here at TigerGraph. And I've been here for several versions of, I've really been here since TigerGraph 1.0. And so it's really exciting to introduce 4.3. This is our latest release. It's built to meet the evolving demands of enterprise organizations by delivering stronger security, deeper integration, and greater scale. These are areas where TigerGraph already excels. We are the premier graph database for enterprises. So things that enterprises need, not just performance, not just scale, but security, and of course, be able to integrate their system into the rest of their ecosystem. That's really every business, small and large, needs to be able to do. So that's obviously very important. And it's these are evolving needs. We were meeting the needs of customers in the early days, and as new technologies develop, the cloud was just coming along. uh, Kubernetes didn't exist when TigerGraph was founded. There are all sorts of technologies that have developed, and AI has arisen, and that creates both new opportunities and new challenges. And so TigerGraph is keeping up. This is our latest, I'm really excited to bring you this update. So as I was saying, security is always important for enterprises, small businesses too, but particularly for enterprises. And I said the landscape evolves. And one of the unfortunate things is that we now have a higher degree of security problems, both various cyber attacks of people trying to break into systems and people trying to commit fraud in various ways, which are overlapping topics. A lot of this is now being enabled through automation and, in particular, AI, which can make even smarter ways to try to attack systems. So it's more important than ever that companies do what they can to protect themselves. A recent Economist article in the Economist magazine says there's never been a better time to commit financial fraud. They were talking about um, the enforcement landscape, but it's also true from the technology landscape because the bad actors now have advanced tools at their disposal, and it's an asymmetrical battle between they only have to succeed a few times to break into your system, whereas the company who's trying to defend, they have to succeed. They have to actually succeed 100% of the time. So that's why it's asymmetrical. Just in the past year, ransomware attacks have gone up with 53% more victims and 45% more attackers. And for AI vulnerabilities, businesses are seeing, they now have deployed AI, some internally, some with external facing applications. When they look at the prompts that the users are submitting, 90% of companies have seen prompts that are risky because they intentionally or unintentionally could be accessing sensitive information. And 40% of MCP servers that have been reviewed actually have some vulnerabilities in their design. So these are serious issues. So TigerGraph, as I said, has kept up with the leading edge. And so in our latest version, we have several improvements in this area. One is we've always had a large portfolio of supported single sign-on services. We're now adding the integrated Kerberos KDC platform to that. We're also adding mutual TLS or MTLS, and I'll explain that in more detail. I'll explain all of these in more detail, but think of this as a key component of enabling a zero trust network. And lastly, as part of our single sign-on process, we create proxy users TigerGraph has created those automatically. We now enable businesses to manage those proxy users directly to have um, greater governance of their system. So I talked about how we have a comprehensive suite of single sign-on offerings. Of course, basically all directory services. The directory service is where the system registers the um, valid users and their credentials so that when somebody is trying to gain access to the system, it checks against the directory to see, is this a permitted user, what are their privileges, etc. The standard for this communication is LDAP, so we of course support LDAP, which is then used by several specific products. We also support federated single sign-on with the identity provider of your choice, and we support the two major standards for this of SAML 2.0 and OIDC. And we, as far as the identity providers, we support many more than these in principle, but these are the ones where we have explicitly validated and provide documented, very detailed instructions about how to set it up. But because a lot of these products follow similar protocols, they actually try to copy each other as far as the APIs. Um, the fact that we support Microsoft and Entra ID, um, Active Directory Federation Services, Ping Federate. These are major platforms, but if Okta is a more open source, well, actually Auth0, I believe, is more towards the open domain. They're more proprietary. Um, so there's actually a lot of we've not really had any problems with our coverage for identity providers. So this has been our main scheme where we support these dominant protocols that the industry has centered on, and which then therefore supports many different individual uh, specific solutions. What we've added recently is Kerberos's latest architecture. Kerberos has been around a long time. They actually fit in this space as well, but they now offer an integrated enterprise single sign-on system, and this is designed for more tightly managed networks, where the communication is between it. Both the clients and servers are generally going to be, um, let's say it's internal users. Even if they are using the public internet to communicate, but all the players are all the users are within an organization, as opposed to this, like, for example, if you have a public website, um, anybody can register and join the network, and then they become known and they'll have some sort of assigned privileges, but this is designed to be for a more tightly controlled network. And so this is something that we now offer. It kind of bundles together both the directory service and the federated IP. Um, so Kerberos uh, is now supported in the for integrated enterprise single sign-on. I mentioned also that we also offer mutual TLS or MTLS. And I'm going to start by explaining what is TLS if you're not familiar. This stands for Transport Layer Security. And what it does is it encrypts the data that you're sending over the network. When you talk to a website, your all of your data going in both directions is digital information. It's on the network, and it's theoretically possible that somebody could be snooping on that, particularly if it's passing through some wireless area. There are other protocols used for wireless communication, um, but for so-called wired communication, TLS as has been the standard. So if somebody could be snooping on that, they could be seeing sensitive information. So this encrypts the information. This the best known example of this, uh, the best known protocol that implements TLS is HTTPS. Most of you have, if you read your web URLs, you see a lot of them start with HTTPS. So it prevents third parties from reading or altering the data. Now, before it actually does that, it has to agree on an encryption and decryption key that the two parties, you, the client, and the server are going to use. Well, how do they do that? So, first of all, the client actually has to verify that the server is who it appears to be. And that's why you, as a consumer, are told to always look for HTTPS, because that's saying, okay, this is following the TLS protocol. I now have some level of trust that I'm actually talking to the right server, and that when I communicate with it, it'll be encrypted. Excuse me. So first, you browse to that website. So you're essentially initiating communication. It sends back a certificate. That certificate was registered with a well-known trusted third party called a certification authority. And what the client then does is it looks at the certificate that was provided by the server and checks it against what the certification authority says it should be, and checks that they match. Now, of course, there's also um, some type of encryption here, or other system to verify that everything is as it should. So once this has been established, the identity of the server has been verified. So you know you're talking to the right server, the one that it claims to be. Then they actually go through a process where they independently come up with the same uh, encryption key. So the encryption key itself is never transmitted. There's an established protocol where they have this information, and they now, from that information, they can build an encryption key, and that is then used to send information. That, in a nutshell, is how it works. So notice what we did was we verified the identity of the server, but we never verified the identity of the client. So here's this gap. What device is it? And I say the client, and I'm talking about the device, not the user. So think of this as the machine, and that's the machine, not the individual user account. What device is trying to connect? Is I'm the server. Somebody wants to read data from me. Is this a legitimate machine? Not just an a little bit legitimate client account, but a legitimate machine. And that gets into this idea of zero trust, that you want it. That's where you want to be very certain about who you talk to. You It could be that somehow, it's either you want to say it's a username password or an access token has been stolen. And so a machine that is not a legitimate machine is using this stolen credentials, user credentials, to access the server. That is something that theoretically could happen with regular TLS. Mutual TLS blocks that, closes that gap. And it's because it requires that the client also has to be verified. And so then the client has to have its authority, its identity registered in a certification authority. Um, and again, this tends to be more. I want to be careful here, but I'll say closed to network again. So where there's a known set of legitimate authorized client devices, and they have to be registered here in the private certification authority. And so in TigerGraph support, what we've done is there's a configuration step where the identity or the address of this private certification authority is entered into the TigerGraph system, so that when a communication is attempted, so TigerGraph is acting as the server. The administrator tells us which certification authority should we use to check the identity of a client. So basically, before the communication begins, both the identity of the server and the client are verified by the other party, then they proceed. So this is why this is TLS was designed for one directional certification. Mutual TLS, as the name implies, does the verification, the certification in both directions. So it was considered, a relatively narrow end case for security, but again, the security specialists saw this, they came up with a new standard, and TigerGraph is now implemented that standard. And thirdly, in this security space, we've added better governance for proxy user management. Now, some background information about what we're talking about here. If you're using single sign-on, that means you have your organization has set up a set of credentials where by signing on here, you're signing on to some part of their whole suite of tools. It's up to that organization to decide which things you have access to, right? That's role-based access control and things like that. But it means you're signing on not just to TigerGraph, but some other additional tools that it decides are within scope. And that's why it's called single sign-on. You sign on once, and then you now have access to these multiple things. So what happens is when we have sort of a layered system where internally we don't use your SSO credentials, we set up a proxy user. So the proxy user has an internal name and internal credentials to allow you to do things within TigerGraph. It's not the same as this external single sign-on identity. So we automatically create a proxy user the first time a single sign-on user is authenticated and granted access, and then it's stored and kept within the TigerGraph system for future use. You'll say you log on today, and then a week later you log on again. It's using the same proxy user identity. And so again, it's not the same identity. Proxy users are only internal to TigerGraph. You can't use this, and it's actually separate from our regular user. We of course have non-single sign-on log on. If you have a standalone TigerGraph database, you can create users and passwords. These are separate from those. What we've added in 4.3 is do the request of some of the system administrators at our customers. You now can directly manage those proxy users. As I said, they were previously automatically created. Now those administrative users can create a proxy user on their own. Why would you want to do that? It enables pre-provisioning. They can basically say when somebody logs on, this is the specific proxy account they're going to have. It enables them to have finer grain control over the name and the privileges of those proxy users so they can review them. Basically, they want to be able to see at any point in time who are all the users on the system, do they have the right privileges, and where do they fit in into different categories of users. Um, and they're just to cover any sort of things that might have been handled incorrectly, they can also explicitly deprovision users, or they can take emergency action that somebody somebody who remains in the SSO system, but we need to remove them, or we need to reduce their privileges on TigerGraph immediately, not relying on the changing the permissions at the single sign-on level. So this gives them the ability to do that. And as I said, because they can now see everything, really understand the proxy users more clearly because they themselves created them and they are managing them, it increases both their internal and third party audits. So that's why we're classifying this not just so much as pure security, but also governance. They have the ability to manage and to explain what is happening in the system. So those three very major improvements. Um, TigerGraph already had very strong security stance. This adds even more. So adding the mutual TLS, the management of proxy users, and the Kerberos integrated enterprise single sign-on. So the improvements in there's actually quite a detailed list of all the things that have been added to 4.3. What I'm covering today are the highlights. You can of course go to our documentation to see the full list. So for today's presentation, I've covered three areas that are in the security area, and now I'm going to cover three features that are in the data integration and data management area. The first of those three is talking about adding more to our data ingestion and data integration area. To be able to use TigerGraph, you of course have to be able to get data in, and getting it in needs to be easy. Shouldn't be the bottleneck. Of course we have high performance within our platform, but you need to have equally high performance and equally easy to use and flexible data ingestion. If you can't get data into the system, it's not going to do you any good. So we're designed for compatibility and flexibility because there are so many different data sources out there, following different proprietary products, different standards, so different protocols they use for communication, different data formats, and different ways that people want to use them. So we do offer a range of different methods. So I on the next page I have a list of some of the major platforms. It's too many to list on this page. The data formats, you have your standard column separated values, you have JSON, and then Parquet data frame, and even Avro for the things used by the data warehouses today. And people want to be able to send that data sometimes in streaming mode where it's kind of coming in continually at any time, or in batch mode where you have a large set of data that you just want to get in as quickly as possible. But most importantly, this is online, meaning that the database can be doing its regular operations, reading and writing, while you're ingesting new data. Excuse me. You don't have to pause the system. You can continue to use your database while you're ingesting new data. All of this can be done with the trademark performance that TigerGraph is known for, high speed. 50 to 150 gigabytes per hour per node. Per node, here I mean in a distributed system, essentially one machine again. So why do I say one machine? Because we are designed to be, from the beginning, we are natively designed to be a distributed database. You set up a single server or single node, you can get this performance. If your data is distributed, partitioned across two servers, you can double that because we're loading data into both in parallel. There be some cross transfer of data? Yes, but that tends to have only a minor effect on this. You get essentially limited speed up, limited scalability for distributed systems. Moreover, you get high availability or resiliency. So if you have replicas of your database, say you have a two-way or three-way replica of your data, each of those server nodes has a loader mechanism. You get more parallelism. So you're loading data even faster. And again, it has the resiliency. If for some reason there's a disruption in one of those servers, you still have all the others which are covering for it. So and also we have automatic restart. So it's not just fast, it's resilient, and we offer many options. What we've added in 4.3 is we now have a direct Lakehouse connector via Kafka Connect. Um, and I'll go in the next page to tell you a little bit more about that. But the keywords here are direct and via Kafka because we actually had a Lakehouse connector in previous versions. So probably I believe in 4.0, it may have even been in 3.10. We've had Lakehouse support through Databricks Delta Lake. But the thing about that is Spark based because Databricks is Spark based. They, of course, are going to design a Spark based protocol. Not everybody there, since their general idea of the lake house became so popular, the being able to have a large store of data analogous to a data warehouse, but with some of the query capability of a database, so that the concept of the Delta Lake became very popular. A the open table format was designed by the open source industry so that okay, you wouldn't have to be reliant just on the Databricks Delta Lake. You there's sort of a competing format, and Apache Iceberg is perhaps the best known player in that space, but there are others such as Hoodoo. Um, so what you can do now with in 4.3 is you can set up a direct connection using Kafka Connect, which is what we've been using for all these others. It's several hundred different data sources uh, adhere to the Kafka Connect standard, and so any data source that adheres to Kafka Connect is a candidate for either supported connection or with TigerGraph or with just a minor, could be very near term on our roadmap. So what we already had, of course, was reading from just files, uh, reading from relational databases with usually JDBC, reading from data warehouses like Snowflake, BigQuery, Postgres. Cloud stores have risen to become one of the most important sources. Um, they have their own protocols. S3 from AWS is very, very popular, but now they have some competition from other cloud stores who say, okay, we're S3 compatible. We follow a lot of the same APIs, but we're not S3 because they're trying to be competing businesses. And so we support both of these as well as as Microsoft Azure and Google Cloud. So we have full coverage for cloud storage. And I already mentioned Databricks Delta Lake. What 4.3 adds is support for open table lake houses such as Apache Iceberg using Kafka Connect. And Kafka has the advantage of the resiliency and distributed nature, so it's a great fit for TigerGraph. It's actually part of TigerGraph's internal architecture, so it's native, it's fully supported. It's not some add-on component you need to plug in and install. It's actually built into the TigerGraph database platform. So that is one of the data integration improvements we have in 4.3. Next is we added support for null values and null value computation. And for those of you that know, you know what null is. For those of you that are a little unfamiliar, it's the way that in a database you represent that you actually don't have a value. You have a place where it would be stored, such as in a table. Think of a empty cell in a table. Um, it's empty because the person who is providing the data did not supply a value. Or, for whatever you perform a computation and the result of that computation is indeterminate. So it's an unknown value. And so what you do is rather than leaving it empty, because empty doesn't really, down at the logic level, it's you get into these very subtle semantics, but null is the signal value to say it's unknown or not provided. Now, it seems if you're familiar with relational databases of for quite a, anything from the 21st century, you think, well, databases just always have null. Well, they didn't always have null, not in the early days. In the early days when the relational database industry and product was still in its early stages, there was a big debate about whether to have null or not. The theorists who conceived of uh, the relational database, sometimes fell on this side where they says, well, from a theoretical perspective, it's actually not there. There's no need for it, and you shouldn't put it in. It's actually adding uncertainty to the system. And why would you want to add uncertainty to the system? So there are people who fought against having null as a value you can store. On the other side, there are people who maybe came from industry. So these I'm not saying it was all, a clean split, but it happens that these two were more from academia, and Ted Codd was also had academic credentials. He happened to be working for IBM, um, a little bit more industry perspective, saying, well, in our real experience, sometimes a value is unknown or missing, and says we actually need to extend Boolean logic to more than just true and false, but need to add at least one and maybe two variations. And because there's actually, notice I have this or here, you could break this into two different use cases. And some people have broken this down into 4 or 6 different variations of null. So Ted Codd, who's sometimes called the father of the relational database, he actually proposed two different variations of null. What came down is the industry eventually settled on a single value of null, um, and most databases went that way. Not 100%, even today, not 100% of databases support null, but most do. That's for relational. Now, when graph databases came up, the question actually, it was an opportunity to rethink this issue and think about, well, what is the best way? And particularly those databases that chose to have a sort of a flexible schema, they weren't sure they actually needed a null because they would simply just say, well, rather than storing null, we simply just have no property at all. There is no property. Um, so what TigerGraph initially implemented was closer to the strict adherence, but not for theoretical reasons. We actually did it for performance reasons. We could design a leaner, meaner machine if we didn't have null. And we listened, but now we've been listening to our customers, and also the GQL standard, the ISO standard, has said that it has support for null. So now that there actually is a standard version of null for graphs, TigerGraph has implemented it. So it actually lets schema designers decide whether will this individual property accept null or not. So they could continue to use their database the way it has been, where you don't have null. You can't have a default value. If a value is not provided, then a default value is inserted. They can decide um, for their individual schemas what they want to do. We've also extended the logic from the two-valued true-false to three-valued true-false null. And again, if you're familiar with how relational databases work, you're familiar with this. And we support the standard schemas for how do you explicitly insert a null, or how does it appear by default because you omitted a value. And if a value is stored and then you read out data, how do you read it out? So we've in 4.3 we've implemented the GQL compliant support for null. That and the reason why we entitle this data fidelity is because it now gives you a more nuanced representation. Maybe if the data you're importing has null, you want to be able to store that in TigerGraph as well. So you're maintaining the consistency between the input data and the from outside and then stored in TigerGraph. That in that sense, it's more faithful to the original format. And lastly, the last thing I'm going to talk about today, I said there are many more improvements in 4.3. More flexibility for data export. So just like I said, you want to be able to read data from wherever you have it. and do it easily. You want, I'm sorry, you want to be able to send your data to where you want, and that should also be easy. So again, similar criteria. TigerGraph is designed for high compatibility and high flexibility. We do run on Linux servers. So of course, the first idea is you write to standard out, which can go to a file. It can stream out, it can be piped to another process. That's up to the user. But it's just sent to this generic uh, output pipe. You can also write to a file, as I said. This is little bit fancier than just piping this to a file. You're actually putting data into an object that remains. You can be updating the object in append mode, so the object is accessible while things are still being written, as opposed to if this is a file, it's you open it, you write to it, and then you close it, and then other people can access it. This is managed in a little bit more object oriented way. Looking back at the connector diagram, if you noticed, the Kafka Connect was for data ingestion, data coming in. The Spark connector is actually bidirectional. It's meaning that from TigerGraph, you can request data to be loaded in, or from Spark, you can send a query and request data from TigerGraph be sent into Spark. So you can actually initiate, think of it again. So Spark is as the client in this sense, asking for data from TigerGraph. And then you can also export directly to AWS S3. What's new in 4.3? I mentioned there's those competing platforms which are S3 compatible. Here's some of the examples of some of them, but there are even more than this. So now there's just a few more configuration parameters you set, and then you're able to export directly from when you read out data from TigerGraph, it goes into this cloud storage. In addition to what we do for flexibility for how you send the data out, of course, also there's access control. Normally, you talk about access control as what can you do within the database, and that includes, do you have the privilege to run a query? Do you have the privilege to read data? But in this case, where also you may have integrated privileges, do you have the right to write to that output file? Um, and so we have both built-in system and user-defined output file restriction policies, particularly for our cloud system, where even though it's a software as a service from your perspective, there's implicitly sort of a virtual server with a file system out there on the cloud. And whether or not you're allowed to write to those files or not is restricted by the system. You can also set up additional user-defined restrictions or policies where you can write or not write. And again, for S3, it has its own integrated role-based access control, and so we have integration with that. So I've covered several things today. I've covered three things on the security area. We now have Kerberos single sign-on to expand our enterprise SSO options. We have mutual TLS so that you can deploy zero trust authentication, authenticating both the client and the server when for communication, and proxy user management to improve the access governance so that administrators have direct control over those proxy users. Three things in the security area and three things in the data management and integration area. The support for OpenTable, Iceberg connectors, and also the ability to export data to S3 compatible cloud storage, and now the support for null three valued logic for GQL compliance and reflect data states more faithfully. So None of these by themselves are why you would buy TigerGraph, because TigerGraph was already serving the needs of enterprises that need to be able to, describe manage their knowledge graphs at scale, performantly, with security, with great administrative control. There's an evolving landscape, and we are keeping up with that evolving landscape. And so we're really excited about 4.3 being the latest step for TigerGraph to for you to remove any operational barriers that you have so that you can deploy AI and other graph applications. So you can actually try 4.3 today. It's available now, so we would invite you to. And thank you for your time. And I'm open if there are any questions.